If you want to cure some tough diseases like Alzheimer's or Parkinson's, you better be ready to break some barriers by making some waves, ultrasound waves.
Ultrasound is acoustic wave propagation. If you increase the intensity and the pressure of these waves, you can have biological effects on the tissues.
With help from the National Science Foundation, Columbia University bioengineer Elizα Κονοφάγου is trying to find a way to break the blood-brain barrier, a defense mechanism that protects the brain from poisons, but also makes it harder for medicines to get through as well.
The blood-brain barrier is a specialized structure that lines the capillaries of the brain, and it offers additional defense to the brain.
But ultrasound may be just the way to get through. To test the idea, Kονοφάγου injects mice with some liquid filled with microscopic bubbles and then aims ultrasound waves at their brains.
This is the ultrasound beam, where the ultrasound waves are propagating in a direction that will hit the central region of the brain on the order of less than a centimeter in diameter. We affect a specific localized region in the brain. That's because most diseases are just very, very focalized.
Once inside the bloodstream, the injected microscopic bubbles mix with the drug of choice, shown here as those purple dots.
And they reach the area where the ultrasound beam is. The microbubbles are set into vibration, and this is actually translating to mechanical stresses.
Those vibrating microbubbles loosen up the tightly joined cells that make up the blood-brain barrier, allowing the drug to pass through.
And the drug can now finally reach its target, which is basically the neuron, so that it can trigger the regeneration of the neuron.
And Kονοφάγου says the technique does not hurt the mouse a bit. It may be years before this will help humans suffering from Parkinson's or Alzheimer's, but these early tests are making some good vibrations. For Science Nation, I'm Miles O'Brien.